Hi everyone, good morning. In this session, I'm going to talk about how to propose a solution architecture design. So here is the agenda. So before we start discussing the how to propose a solution architecture design, it requires to understand some basic foundational concepts. So our main key solution is vSphere with Tanzu. So let's understand what is vSphere with the Tanzu high-level solution architecture, and what are the key objects in vSphere with Tanzu, and what are all the benefits of vSphere with Tanzu, and what are the customer requirements, and how to propose a solution architecture design. And as part of the design, we should also understand how to organize a sizing for workloads, and how do we get the license requirements, and how to organize a scope of work or statement of work. Okay, let's dive into the concept now. So what is vSphere with the Tanzu high level solution architecture? So solution architecture here is the high level solution architecture. Let's try to understand the diagram first. Normally, as we are aware, vSphere means it's a consist of ESXi host and vCenter server. But vCenter server is not for a single ESXi. It allows you to manage multiple ESXi hosts. So that's the reason in this architecture we mention as ESXi cluster. So cluster minimally VMware recommendation starts with a 3 ESXi host, and we can configure the ESXi host within a cluster until 94 ESXi hosts. To manage all ESXi host and virtual machine communication, we require a networking. So we can use a based on our customer license, we can use either virtual switch or distributed virtual switch. And storage, we have multiple options. We can use either FCSAN storage, iSCSI SAN, NFS storage. We can use vSAN, virtual SAN, virtual volumes. It's subjected to be customer's choice. And until this part, we already aware this concept, and to manage this environment we require a vSphere administrator. But now the what is the key concept in vSphere with Tanzu is also it's integrated with vSphere only. If you configure a vSphere with Tanzu, it's a configure a supervisor cluster. If you see this icon is like a Kubernetes icon, but why VMware they mention the name as Tanzu is it's a enterprise grade Kubernetes application name is Tanzu. Okay, but same like our vSphere, we have ESXi cluster concept. Same way in our Tanzu also, it has a cluster concept that is called supervisor cluster. This supervisor cluster have multiple services like a Tanzu Kubernetes grid service and also a VM service. To access this Tanzu Kubernetes cluster, VMs and also the parts, we require a developer user. Normally, DevOps administrators used to connect to the supervisor cluster virtual machine service. Okay, and apart from this, we are using a vCenter server ESX. Main our primary benefit is creating of virtual machines. But when we integrate with a Tanzu, the additional advantage is we can it allows you to configure vSphere pod, and it will allow us to configure as Tanzu Kubernetes cluster. This Tanzu Kubernetes cluster consists of a control VM and worker node virtual machines. So this is the high level architecture. It is considered as a vSphere with Tanzu. So let's understand the description. vSphere with Tanzu transforms vSphere into native Kubernetes platform. And a cluster that enabled with vSphere with Tanzu is called supervisor cluster. Okay, now understand what is the key objects whatever we discussed in the our architecture, the same we also consider as a vSphere with the Tanzu key objects. Let's understand the key object in a systematic way now. So what are the key objects in vSphere with the Tanzu? So here is the high level diagram. When we install a vCenter server, see we have vCenter server. Under vCenter server, we can create a data center. Under data center, we can create cluster and add 3 ESXi host. So if you enable vSphere with the Tanzu feature, that Tanzu feature we can enable using a workload management. When you enable workload management feature, it will allow you to configure the namespace. See, the first item is considered as a namespace. Under the namespace, it allows you to create a multiple vSphere pods. So the second option is showing us vSphere pods. And apart from vSphere pod, we can also configure Tanzu Kubernetes cluster. See, you can see the icon as a grouping of three. Same like how our vSphere cluster grouping of multiple three hosts is considered as cluster icon. Same way, Tanzu Kubernetes cluster also have a three grouping of three namespaces. That icon is considered as a Tanzu Kubernetes cluster. Under Tanzu Kubernetes cluster, you can configure a multiple VMs. That is like a one is control plane VM, or two are the worker node. There is no limitation. You can configure three worker nodes, three control plane nodes, depends on your application requirement. Okay, and also another point is another key object harbor registry. Earlier, if you want to configure a harbor, we have to use a external software to install the harbor registry. But when you are using vSphere with the Tanzu, we have a embedded harbor registry feature. When you enable harbor registry, you will find all these harbor components will get it installed in our vSphere environment. Okay, and apart from that, the main key component is control plane VMs. We have supervisor control plane VM 1, 2, and 3. This three supervisor control VM is considered as a supervisor cluster. Whatever we discussed in our architectural diagram, this is the supervisor cluster, and we have a vSphere pod like harbor registry, and we can configure Tanzu Kubernetes cluster. And apart from this, you can also configure a specific vSphere pods. So when you enable a vSphere with Tanzu, okay. And now let's talk about what are all the benefits of vSphere with Tanzu. So here is the main benefits of vSphere with Tanzu. So deliver developer ready infrastructure by allowing IT teams to use their existing vSphere environments to rapidly deploy Kubernetes clusters for their development teams. So normally we use the Kubernetes in our test environment, but for the production environment, it's always recommended to choose enterprise Kubernetes only. So vSphere Tanzu is one of the popular enterprise Kubernetes platform. Okay, and a simple enablement wizard gets us up and running in minutes. So it's a very fast deployment. And we start with a set of ESXi hosts managed by vCenter. This is only our initial start. And vSphere Tanzu is the fastest way to get started with Kubernetes workloads. And this is icon for Kubernetes, but when comes to enterprise Kubernetes, this is the icon. And configure an enterprise grade Kubernetes infrastructure on our choice of networking, storage, and load balancing solution. Here on our choice means networking, you can configure either using HA proxy, or you can configure a NSX AVI load balancer, or you can configure with NSXT. We have a three options. Even in the storage, as we know, storage we can use virtual SAN, virtual volumes, or you can use FCSAN, iSCSI NFS. Whatever your customer is recommending, based on the customer budget, you can choose the relevant storage. And load balancing also similar. You can use either VMware supported load balancer, or you can use any of the external load balancers. Okay, this is the benefits of vSphere with Tanzu. Now, before we understand the how do we propose a solution design, in general, first we need to contact our customer. We should have a customer conversation. During the customer conversation only, we can gather all our customer requirements. So here is one example I'm giving. So the similarly you can correlate with your experience. Normally when we contact our customer initial conversation, they will come up with a their workload requirement is vCPU minimally 160 and virtual machine memory 540 GB and storage approximately 440 TB and the GPU graphical processing units are 5. This is the actual customer requirement they given. They requested us to propose a solution with supported for a container as a service. That is the customer actual requirement. Now, before we provide a solution, just now we talk about some basic functionality of vSphere with Tanzu. Tanzu is a enterprise Kubernetes platform. It is also provide a container as a service. Okay, so once we collect this customer requirement, now it's a good time to propose a solution architectural design. Okay, so let's start explaining you the how to propose a solution architecture design. So we already decided our solution must include with a vSphere with Tanzu. But how about the designing diagram? Normally the designing diagram, usually the solution architects, they prepare the design diagram using a Microsoft Visio. We can prepare the architectural design. That is one method. Another method, you can use any of the other third-party sites like a draw.io. Using that site also, you can prepare the solution architectural design. For our easy understanding, I am showing you the design from our slide deck now. Let's say as per the customer requirement, we already decided vSphere with Tanzu. So even that, based on the initial conversation with customer, we should decide that customer also did not have any external storage device. They already proposed for a 40 TB requirement. So 40 TB means, so for better solution is we can propose for a HCI solution. HCI means hyper converged infrastructure solution. So hyper-converged means hypervisor converged with storage. So that means the main products are core HCI product is vSphere plus virtual SAN. So if you want to configure ESXi host and storage, we need a hardware. So based on the customer requirement, CPU, memory, disk and GPU, the best option is we can, sorry, I accidentally pressed the end button. Yeah, this is our slide. So we connected the hyper-converged infrastructure vSphere plus virtual SAN. So on top of that, we need to configure as part of our solution architecture design, we need to configure a our main physical hardware. So you can choose any of the hardware vendor. So for our easy understanding, I just select the hardware vendor as HPE. So for the our given customer requirement, I selected the server hardware. Minimally, we need a 5 server hardware. And also we have to choose the model. For example, I am choosing the model as HPE Proliant DL380 model. Okay, that model is finalized and we have chosen the 5 servers. And on top of the servers, what is the recommendation is we have to configure a vCenter server. So vCenter is a vCenter server appliance. This appliance, it will help us to manage all our ESXi host, and also it will help us to configure the cluster. So cluster means in our vCenter cluster, it have a features of HA, DRS and virtual SAN. When you enable a virtual SAN, what will happen is whatever our hardware have a physical hard drives, all our hard drives, all flash hard drives, it will become as a disk group. Using all these servers disk group, we can configure a one common virtual SAN data store. So our architectural design diagram must consist of all these components. So once the vSAN is ready, and also to communicate between all our ESXi host and production virtual machines, we require our distributed virtual switch. So distributed virtual switch network also needed. And again, if you want to configure on top of the vSphere plus vSAN, it's the right time to enable a workload management feature. Normally the workload management feature, let's quickly log into our lab system. Let me show you where we can see the workload management option. When we log into our vCenter server, go to the vCenter server menu and you can see the option for workload management. When you select workload management, you can see workload management enables deploying and managing Kubernetes workloads in vSphere. Okay, this is the only the option will help us to configure a prerequisites for setting up a supervisor cluster. So this is where we can set up the supervisor cluster. Suppose if I click on get started option, it will start configuring a supervisor cluster within our vCenter server. In the right side, you can see view prerequisites. When you click on view prerequisites tab, you can see there is a list of prerequisites to configure supervisor cluster. Our cluster must have HA and DRS enabled, and also storage policy is required. This storage policies we can configure in a either virtual SAN or we can configure in a virtual volumes. Suppose the storage policy default virtual SAN policy also we can use. And also in addition, we require, when you are using a distributed virtual switch, we require a load balancer. This load balancer can be, you can use either a HA proxy you can use, or you can use NSX advanced load balancer. Any one load balancer is needed if you're going with a virtual distributed switch. And also it provide, when you enable a supervisor cluster, it will provide a service called Tanzu Kubernetes Grid Service. This service also available, and it require a content library. Content library is within our vCenter server feature. We can create a content library easily. So these are the four requirement to configure a supervisor cluster. This is the one scenario. And scenario two, if you want to configure a supervisor cluster using NSXT, so select NSX, you will see three options. Compared to previous option, we have four methods because load balancer we are creating separately. But when you select the NSX, the load balancer option is excluded because NSXT itself we have a load balancing facility. But only thing is NSXT license is bit costly when we compare with any of the HA proxy and advanced load balancer. Normally advanced load balancer require licenses. HA proxy is like a open source only, but normally in a production environment, it's always recommend to use either NSX advanced load balancer, or you can use a NSXT licensing. But that is also during the discussion with customer, we have to propose two options. Whether the customer is agree to buy NSXT, we can propose the NSXT solution. If the customer is not agree for a NSXT license, if they are not happy with NSXT license cost, we may choose the customer with NSX advanced load balancer. Okay, so that is a reason in our architectural diagram we have to choose distributed virtual switch, and also we have to choose advanced load balancer. Okay, let me minimize. So now we are configuring a supervisor cluster. Supervisor cluster means it consists of control plane VM1, control plane VM2, control plane VM3, and we are using a distributed virtual switch. So distributed virtual switch means we have to use a additional load balancer because HADRS and virtual SAN is ready and DV switch also ready, and we need a additional component is NSX advanced load balancer. This is the icon for a NSX advanced load balancer. And additional design is on top of supervisor cluster, we can configure a namespace. So initially, most of the designs initially we should start with a staging or QA environment, testing environment. We can start at the initial stage. On top of the namespace, we can configure Tanzu Kubernetes cluster. That cluster consists of multiple control plane VM, worker VM, and even you can also configure a pods also within your Tanzu Kubernetes cluster. That is the staging level. Same procedure we can also deploy for a, once your test is successful, we can prepare a namespace for production. Even in the production also we can configure the Tanzu Kubernetes cluster and configure control plane and worker VMs, and also along with you can configure vSphere pods. Okay, so this is the high level solution design we are going to propose it to the customer. But while proposing the customer, we already have a initial conversation with customer. We gather the requirement. Based on the requirements only, we can prepare this solution design. Okay, so this solution design, the key points are we already finalized how many servers are needed. This how many servers we selected as 5 server, but how we concluded with 5 servers are, that information you can find from a vSAN sizing facility. That point I will explain in the following slide. Okay, so this is how we'll prepare a solution architecture design when we doing a solutions. Okay, now another point is here, if you see here, earlier this is a solution architecture design, but in our requirement customer also specifically mentioned that GPU, graphical processing unit, that means they are planning to use containerization applications for video analytics application. When you are planning to use video analytic application, even including our server hardware, we must come up with a server with GPU processor. So each server we have to include a GPU processor. GPU means graphical processing unit. It will support for most of the graphical applications and also graphical analytics, or if you are performing any video analytics application, it require each server must run with a graphical processor. Okay, the graphical processor, this is a symbol I'm showing you in the diagram. Graphical processor unit is needed for each server. Okay, so now let's talk about the how to organize a sizing for workload. Customer already given the requirement, but if you want to provide this requirement, we should also require some management compartment. Management compartment means ESX consider as management compartment. vCenter also we have to install. So vCenter also requires some CPU, some memory, disk and NIC. And same way supervisor cluster, vSphere pod, control plane VMs. This all we have to do some sizing preparation. So now I will show you how to organize a sizing for workload. So before showing you the complete picture, I'm taking one example of vCenter server. As we are aware, vCenter server, we have a different type of t-shirt sizing. If you are deploying a tiny size, minimally 2 CPU, memory 12 GB, and hard disk size is 579, it will support up to 10 ESXi host and virtual machine 100 virtual machines. And small size means 4 CPU and 19 GB of memory, and storage is increased to 694. Host it support for 100 hosts, and VMs are 1000 VMs it supports. And if you increase to X large means obviously CPU count increase, memory count increase, and it's supported for 2000 ESXi hosts, and virtual machines are 35,000 virtual machines. So but our current requirement is customer requirement already given. So based on the customer requirement, we should choose either tiny, small or medium. So for example, we are choosing the size as a small size vCenter. Similarly, we have to choose the sizing requirement for other components, other management components like vCenter server with content library, 4 CPU, 19 GB. But for CPU, we came to know from our actual appliance size for small is 419. This values only I mentioned in this table: 4 CPU, 19 GB, and 694 GB. But the vCenter count is only one, so total CPU, memory, and the total GB is same size. And control plane VMs are 3 VMs, but each VM we require minimally 8 virtual CPU, 32 GB memory, 32, and we have to multiply with the 3. This is the total value. Same way we can write all the sizing for worker node, AVI controller, that means NSX AVI controller, service engine, supervisor cluster, and also we have to include for a harbor registry. This is a just example table I've given. Similarly, you can perform when your customer is asking you for a sizing requirement. So this is one example table. Okay, and this sizing information, this is for a management compartment. Similarly, we have to include our customer workload requirement, and you can make the total of CPU, memory, and disk size. Sometimes if you have any queries on sizing requirement, and during that scenario, we can log into our any of our VMware website. You can just use the keyword vSAN sizing. Let's say if you search with a vSAN sizing in Google, just type vSAN sizing, you can find the first link, virtual SAN ready node sizer. Just open this link, and this link will also help us to do better sizing plan. Really how many physical nodes are needed, and each node how many hard disk we can insert. That sizing plan we can perform using this VMware website, vsansizer.vmware.com. Uh, okay, my internet is a bit slow. Okay, let's wait for a minute, it will load. Okay, so vSAN is vSAN ready node sizer. As we know, vSAN is supported for disaster recovery applications. We can use database servers, we can use VDA virtual desktop infrastructure, remote office, branch office also we can use vSAN. Okay, and while login we can use our email address and also the password. And if you have a partner, you can choose partner ID. And if you are my VMware account, you can just select my VMware account and click on sign in. Once we log into the vSAN Sizer, there is a option to do our sizing. Let's say there is a my projects or vSAN Quick Sizer tab. You can just click on vSAN Quick Sizer tab. In this vSAN Quick Sizer tab, vSAN we can configure in two methods. You can use either all flash disk or hybrid. Hybrid means mixed of HDD and SSD, or nowadays most of the organizations they are using a all flash. So better choose all flash. And vSAN version, we have version 6.7 to 7.0 update 3. So let's choose the latest version. And ready node. we have to choose all flash, which is the all flash, and ready node vendor. Currently, we have multiple hardware vendors, Cisco, Dell, HPE, multiple vendor. For example, I'm choosing the hardware vendor is Hewlett Packard Enterprise, HPE. So when we select the hardware vendor, and we have to choose the ready node profile, all flash 4, all flash 6, or all flash 8. Whatever you are comfortable, you can choose the one all flash 8. Let's say choose the hardware vendor, and also we can find the respective hardware models. Within all flash 8, we have so many supported hardware model: HPE Apollo server, HPE DL360, DL380, and we also have multiple models. For example, I'm selecting a HPE Proliant DL380 generation 10. So when we select the hardware model, and we have to choose number of servers. Generally, vSAN recommendation minimum is 3, but as per our current customer requirement and also our management compartment requirement, minimally we need a 5 ESXi host. And the disk group, how many disk group we plan to choose? You want to choose 2 group or 1 group, but as a initial start, we should go with a 1 group. So that time we also choose the capacity per disk group, either 6, 7 disk or 6 disk you can choose. But our customer requirement is 50 terabyte. We'll randomly check. Let's say I'm choosing the disk group as a 5 disk groups. Within the one disk group, we have a 5 hard disk on each server, and the capacity we have each hard disk 1 TB, 1.6. Let's say, for example, I'm choosing a 3.84 terabyte. And fault tolerance for RAID 1, we can choose any one RAID 1 or RAID 5. Let's say I'm choosing FTT to RAID 1. During this scenario, we have multiple options: compression only, deduplication plus compression, or none. Let's say first calculate without any compression and deduplication facility, how much disk size it is providing. When we choose a 5 servers, click on calculate. When you click on calculate, it will help us to do all automation calculations. See, the usable capacity is 20 terabyte, but our customer requirement is 50 TB. So this 50 TB is not enough with this sizing. So that means what we can do, either we can increase the server count or we can increase the disk count. Let's say within the server, instead of 5, I'm increasing the disk count to 7 for testing purpose. Let's click on calculate and verify that how much total usable size we can get now. Let's say total usable size is 40 TB only, but we need minimal size is at least we need a 50 terabyte. So 50 terabyte means we can change the either server count we can change, or we can change the disk group. Let's say I'm just testing with a another 8, one disk is increased. It seems the minimum is 1, maximum disks are 7. So we cannot change the disk size. Let's say we can increase the server count. Let's say I'm increasing server count to 6 servers. So click on calculate. So when we click on calculate, now the size is 73 TB. And let me see here, instead of 3.84 terabyte, suppose I'm choosing the size as 4 TB, and let's make this as a 5 servers. Now click on calculate, whether the equivalent size we will get or not. See, now the size is 63 TB. So this is the best option to suggest to the customer. Still within the 5 server, and disk capacity for each server is 7 disks, and 7 disk we are making a disk group, and the capacity for each hard disk is 4 terabyte. And also RAID 1, if you want to change to fault tolerance 2 also, let's see any size difference in the FTT2 RAID 1. If we choose FT2 RAID 1, we are getting only 42 TB. So we can choose either 41, FTT1 RAID 1 means we are getting some additional capacity. So this failure protection is, we can suggest to the customer, if they use FTT1 means they can get 63 TB. If they are using a FTT2 means they will get the capacity is only 42 terabyte. Suppose if we change it to FTT1 RAID 5, let's see the how much the calculation we can get. It will equivalent to 95 TB. So even RAID 5 also we can recommend. So this depends on the customers. We will provide the multiple sizing option. So whatever customer is chosen or happy, we can choose. Suppose FTT2, instead of none, if we want to choose a compress only, let's see the compress only option. See, this many options we have to while doing the sizing. Okay, so when we select compress only also, it's equivalent to 49.4. Even this option also quite okay. Okay, so I repeat, we choose the configuration type all flash, vSAN latest version, and server model we selected HPE and HP ProLiant DL and all flash 8, and we selected servers 5, capacity is this one, and when we click calculate, we are meeting the actual customer required total storage size. Okay, this is how we'll perform the calculation. Even if you want to export this information, we can just click on download, you will find the report. So vSAN proposal. So this will provide you the all the sizing information. This is how we'll do in the real world scenario also. Okay, suppose once we downloaded that PDF, just open it, you will find whatever we selected option, all options you will find. Let's say vSAN proposal. You can see we are proposing for a core HCA. That means virtual SAN with vSphere, and we are using HCA introduce a new consistent operation model, and whatever selection we selected, that sizing information you can find here. Configuration type, you can see ready node configuration all flash, and also you can see failure protection is FTT2 and vSAN version is 7.0 compression only, and also operational reservoir false and vSAN license is standard license. Okay, and we did today, and capacity distribution is supported for 49.4 TB. This is the actual usable capacity. Okay, so this information also we can send it to the customer. And available memory, for required memory for this all the disk operations, it required minimally 339 GB available memory, and vSAN memory overhead is 44 GB. Okay, so memory distribution information also they given very clearly, capacity distribution also given accurately. Okay, so this is how we can do the sizing. So I given an example, same way you can also propose it to our customer how we can organize the sizing for all workloads. Now coming to the another key point is how do we get the license requirements? Normally the licenses, when we see the architectural design diagram, we require a hardware licenses, we require a software licenses. Normally the software, most of the software is VMware products only. So VMware products NSX AVA license we need, and vCenter license, vSphere license, vSphere with the Tanzu license, and vSAN license. So these part numbers and all we can get it from a VMware website, or you can ask our VMware solution sales team. They will help us to provide the part numbers. Part number is nothing but it's the same like product name only. NSX ALB Advanced Load Balancer product SSC. That is and all part number codes given by the VMware. And for our design perspective, we need one NSX load balancer license, one vCenter license, and 10 ESXi host. That 10 means we are choosing 5 hardware, but each hardware have a 2 CPU, so we need a 10 quantity license is needed, and virtual SAN also per CPU based, so we need a 10 quantity licenses. This is how many licenses also we needed, we should propose it to the customer. Okay, and finally, how to organize an statement of work. Our actual statement of work or scope of work we have to provide. As we know, we have a main thing is design. Day zero we can do the design we already prepared. We spare with the Tanzu solution architecture design. And deploy, this is the only the deployment portion. So deployment portion is HCI vSphere with vSAN implementation. First we have to implement ESXi installation on 5 server, and then vCenter installation and configure the cluster, and we can start managing our vCenter server. Managing means we can create the data center, add our ESXi host to the vCenter, and enable HA, create a cluster, enable HA, DRS, and virtual SAN. All our vCenter activities are nothing but a vCenter server data operations. But initially we have to deploy. This is our initial day one implementation tasks. And after that, we have to configure workload management vSphere with Tanzu implementation. We need to configure Tanzu supervisor cluster, and once we configure Tanzu supervisor cluster, on top of that, create a namespace and configure Kubernetes cluster creation, and also integrated with a NSX AVI load balancer. It will provide a load balancing. Okay, and also we can enable a embedded Harbor registry to push all your Docker images here. Okay, so this is the statement of work we can provide it to the customer. And operations and all, it's like a day two operation. Once implementation is completed, we can perform the day two operations, and finally we can do the life cycle like updates and upgrades. Okay, hope you understand how do we propose a solution design to the customer. Okay, that's it for today. Thank you. Please do view, like, share, and subscribe to my channel, Gnan Cloud Garage, if you are watching this video first time. Okay. If you are already subscribed, thanks for your support. It's really encouraging me a lot to do the more technical videos. Bye for now.